Hey everybody, I'm Mr. Watchers from Montview. I'll be doing some of the videos this week about waves, and I'm really excited to do waves because waves are one of my favorite subjects. It's really cool to think about how waves can be used when it comes to the ocean and surfing and tsunamis, or how we can take those same principles and apply them to waves that allow us to use telescopes and discover distant galaxies. And so we'll talk all about waves, and it's really cool if you've been frustrated with the kinematic section or the forces. This is a new opportunity to kind of think about it's a new unit, new equations, all that. So I hope that everyone sees it as a fresh start, starting with e-school, getting excited, and all that. So first, we're going to talk about whether waves have energy or not. I'm going to show you two different waves that are comprised of a slinky. So here somebody's shaking a slinky up and down, and that motion is carrying all the way forward. And somebody's pushing a slinky together, and that compression is carrying all the way forward. And so here, it's easy to kind of look at this and say like, well, I don't know if it has energy or not, right? It's just a slinky that's moving. But if we think about it, we actually talked a lot about a specific type of energy that has to do with motion. And that specific type of energy is kinetic energy, right? And so waves carry energy forward. And that's a really cool concept because the energy starts at one place and then ends up at the end. Here, this thing is looped, but you can see it's starting at one end of the screen and carrying all the way over to the other end of the screen. So we know waves have energy. The second thing to talk about is how different types of waves move. And here you can see there are two different types of waves, transverse waves and longitudinal waves. And when we say transverse waves, we say that the motion is perpendicular to the wave propagation. And that sounds really fancy, and this is on your homework, so pay close attention here. So when we talk about perpendicular, perpendicular means it has a right angle with something, right? And we know that the wave is traveling left to right. And so our motion of propagation is left to right. But how is our medium, the slinky, actually moving? If I pause this real quick, I'm going to hold my mouse cursor right here, right before the wave starts, and move through this in slow motion. And here you can see that the slinky is actually moving up and down. It's not moving left to right at all, right? The slinky stays in the same place after this wave propagates. And so so that's how transverse waves work. They move up and down. And when you look at longitudinal waves at the bottom, it's actually the opposite. They move parallel, right? And so here, if we look at this video, you can see that the slinky gets stretched, right? If we look at this point right here, the slinky actually moves to I'm going backwards. You can see that the slinky actually moves to the left, right? It actually gets stretched out. It's moving over there, and then it comes back, it goes forward a little bit, and then returns to its original position. And so transverse waves move perpendicular, longitudinal waves move parallel. In the next video, I'll talk about how we can define terms on waves, and I'm looking forward to seeing you all then. Thank you.